From last class, we have a few concepts that I would like to review. And can anyone help us with the first one? When solving a radical equation, we always have to in the original problem. I need help, please. No volunteers?
Check the solution.
Say it again.
Check the solution.
Very good. The prospect, solution, back in the original problem. Mandatory. Excellent. Can anyone tell us how to factor the sum of cubes or the difference of cubes? Sum of cubes or difference of cubes? Anyone, please? So remember, the correct answer has to be a binomial times a trinomial. That has to be the correct answer, the first step. A binomial times a trinomial. So, can anyone give us the binomial for either one? You choose. Anyone, please?
A plus B.
Good. So it's either A plus B, and if it's the minus 1, it will be in minus. Good. Can anyone give us the trinomial for the plus? And then we'll make a minor change for the minus.
A squared minus AB plus B squared.
Excellent. So of course, if I have minus here, I have to have plus in the middle. So remember, plus, plus, minus. Minus, minus, plus. Plus, plus, minus, 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 plus. Good. Can anyone give us the A plus B squared so we can forget about this? Anyone? Please. Blake, Kevin, anyone?
A plus B times. Oh, I'm sorry.
That's okay.
I don't know. Sorry.
This is a very important formula. We discussed it last time. So it's a squared plus 2ab plus b squared, and if the formula, or if the binomial has minus, then we have minus here. And this is, please understand that these are basic formulas that we need to know at all times. Can anyone factor this for us? So of course, these formulas are back and forth. If I have this, I can factor it like this. If I have this product, I can multiply it and get a cubed plus b cubed, or a cubed minus b cubed. Same thing here. I may start from here and get this, or I may start here and get this. Okay, a squared minus b squared. Can anyone tell us how to factor that? Anyone, please?
Would it be A plus B, A minus B?
Exactly. Good. Let's suppose we solve a polynomial equation, and the polynomial in that equation has degree 5. How many solutions will we find? 4, 7, 2, how many? Absolutely 5. What if the degree is 15? How many solutions we have to find?
15.
15. Excellent. It's always the case. Always. Okay, perfect. So we're back now to the handout that we did not finish last time. And there were a few things that I'd like to review before we continue. So we looked at solving equations. And the first one was by factoring. That was our first method. So we solved equations by factoring. There are many other methods. So I would like now to look at the method of substitution. Substitution. And the question is why? Why do I care about using a substitution? Okay, here's the answer why. So this is my page 2. Okay. So, and I'm back to the handout, and I would like you to choose. You would like to start with 64 or 72. If you can't see here, which is very possible, you have the handout posted. Which one would you like to start with? 64 or 72? Okay, 64? Okay, so let's look at 64. So we have 2x to the 4th minus 5x squared and minus 12. And the question is, find the real zeros. So solutions to equations can be real solutions, or imaginary solutions. We don't have anything else, either real or imaginary. So in this particular case, they're giving us a function, and they're asking us just to find the real zeros. Okay, what do I have to do to find this? So the label of this is uppercase f of x. So what do I have to do to find the zeros in general, the zeros of a function? Can anyone help? To find the zeros of a function, what do I need to do?
Set equal to 0.
Yes, set the function equal to 0. So we have f of x is set equal to 0. Awesome. Very good. So then I have 2x to the 4th minus 5x squared minus 12 equals 0. Yes, the degree is
4.
4. How many solutions do I have to find?
4.
4. They're asking us specifically, thank you so much, Kevin. They're specifically asking us to find the real solutions though. Okay, fine. Notice that the degree, as you mentioned, is 4. Some polynomials, not all, or some expressions, some expressions are something called quadratic in form. What is that? Quadratic in form. Well, they can be replaced by a quadratic equation. Not everything can be replaced by a quadratic equation, but some expressions, if you want some functions, are quadratic in form, meaning they can be replaced by a quadratic equation. And what's the use of that? Making my life easier. That's the use of it. And I notice here that if I say let y, let's say, be x squared, in other words, this piece, I denote this piece by y. If this piece cannot be replaced by y squared, if it cannot be replaced by y squared, then the equation or the function is not quadratic in form. But if I square x squared, do I get x to the 4th?
Yes.
Yes. So because I do, then I will consider this equation quadratic in form. In other words, I can replace it by 2y squared minus 5y minus 12 equals 0. So before we continue here, I just want to show you a counterexample. So let's say I have y to the third plus y squared plus, let's say, 5 equals 0. Is this quadratic in form? No. Because if I denote this piece by t, this one is not t squared. Because when I square y squared, I get y to the fourth, not y to the third. Can I solve this? Potentially, but not as an expression or an equation quadratic in form. I have other methods, or calculator, or something else. But I cannot use the method of substitution. I used the substitution. I said, let this be y, because this is y squared, and I can change the equation into 2y squared minus 5y minus 12 equals 0. So now, since we haven't talked about we haven't talked about how to solve quadratic equations using the quadratic formula, let's still stick with factoring. And remember, descending order, yes. Greatest common factor, none. Negative leading coefficient, none. Special product, no. This is because this is negative 12. Is 1 a leading coefficient? No, I wish. So this is my last hope. The last one. So I need two numbers whose product is and whose sum is. Can anyone tell us the product?
Negative 24.
The product is indeed negative 24 because I have to involve the leading coefficient. 2 times negative 12 is negative 24. Excellent. And then the sum, that never changes. And remember, we take the numbers with the sign in front. So the sum is negative 5. So I need two numbers whose product is negative 24 and whose sum is negative 5. And I know they must be this and that. And what do I do next? Can anyone give us those numbers?
4 and negative 6.
But 4 and negative 6 will not give us negative 5. So 4 and negative 6 will not give us negative 5. So it's correct here, but not here. So the numbers, it's a very good point. Thank you for saying that. Because we need to discuss these things. So we cannot just choose something that works in one or the other. We have to choose something that works in both.
Negative 8 and 3.
Negative 8 and 3. Thank you. Who was that? Thank you. Okay. I don't know who said that, but that's okay. Good. So now remember what we do. We are going to involve factoring by grouping, but not before we change the equation. That's my page 3. Good. So we have 2y squared minus 8y plus 3y, which is the same with negative 5y, and minus 12 equals 0. Perfect. What next? What is my next step?
Factoring.
Yes. So I factor by grouping. So what do I factor out from the first two?
2y.
Good. 2y. Good. What is left? In parentheses?
I minus 4.
Good. What do I have to get from the other two before I even look? I have to put it in before I look, just in case, to avoid potential mistakes. If it's not there, then I cannot continue.
A plus or a minus sign?
Nope.
Y minus 4.
It has to be the same thing. I must copy it now here. And now I look. Remember, I need the sign and the factor. I need the sign and I need the factor. Just the factor will not be enough.
Working.
Very good. What is the common factor now that goes out?
2y plus 3.
The common factor that goes out is y minus 4. What is left in parentheses?
2y plus 3.
Very good. So we have two options for y. What are the options for y?
Positive 4 and what's that? Negative 3 over 2.
Excellent. Is this good? It's excellent. But it doesn't solve the issue. I have to go back. Yes, go ahead.
You say before we move on that the y minus 4 on one side has to match the other. Why is that here?
That's the rule for factoring by grouping. Once I found those numbers, I know that when I replace the middle term, which was initially negative 5y, I have to find a common factor. If it's not there, then nothing works. It's the only way for this to be a common factor go in front and then 2y plus 3 in the second factor. It's mandatory.
Okay.
You cannot continue. If this doesn't work, you cannot continue. But it has to work because we found two numbers whose product is negative 24 and whose sum is negative 5. So it's a must. This factor that is coming out from here has to be here. Now, it may not work grouping these two and these two. So I have to try these two and these two. And finally, I have to try these two and these two. But not in this case. Okay? So we always try the first two. Whatever comes out should come out from the other two, mandatory. If it doesn't, then we're stuck. We can't continue. We cannot finish factoring. Any questions? Good. So this is okay, but this doesn't solve the problem simply because we have to go back. Our y is 4 in this, not x. So now I have to solve two new equations. And they are x squared equals 4 and x squared equals negative 3 halves. And now we have the option of using the method, the third method. So we looked at solving equations by factoring and then by substitution, which is just this that we are doing right now. And now we will continue with taking square roots. We will have more examples later. Okay, so let's start with the first one. What type of equation is this?